Hi, everyone. Thanks for joining today's community call. Wanted to welcome everyone. And you might notice in this webinar interface, there is the chat interface on the right. So as we're doing some welcomes and going over today's agenda, please chime in and let us know where you are watching from. So we have usually a very international audience, so it's always fun to see where people are coming from. Personally, I'm in the US, based out of Washington State. And why don't we start off with some introductions? My name is Steve Yee. I lead growth and marketing at Serverless. And we've got a great agenda today. So we're going to start off with Gareth, who's our developer advocate at Serverless. And he's been working on some great guidance for how to structure a serverless application. And then also doing a brief demo on our upcoming product called Serverless Console, which adds a lot of great features around observation and monitoring to your serverless apps. Then we're going to transition to Purple Technology, which is a financial services technology firm that helps traders based out of the EU. And they'll be telling us about their serverless story and their journey using Serverless Framework and some of the benefits and how they architected their application. And so that's going to be led by Filip Pyrek as well as Jan Červinka. And for folks who are interested in watching this later or forwarding this on to your friends, we will be sending an email after today's call that will contain the replay link for the webinar. And we'll also be posting this on YouTube and then on our blog in the next couple of days as well. So we also want to make this as interactive as possible. So you'll also see next to the chat button or the chat window, there's a questions tab. So if you have any questions, we'll stop periodically every couple of slides or so, enter your questions in the questions tab, and then that gives an opportunity for other folks in the audience to actually upvote your questions as well. So some people might have the same question, and if it's something that a lot of people are asking, we'll know that, and we'll make sure to address it. So why don't we go ahead and get started, and let me hand this off to Gareth, and he can share a preview of some of the guidance and he's developing for his serverless guide on structuring serverless applications. So Gareth, take us away.
Thanks, Stephen. So what I wanted to chat about today, as Stephen mentioned, we're busy putting together the serverless guide, which is our input into building serverless applications, maintaining them over time, and a lot of sort of good advice that we want to share with the serverless community. And starting with this, we're looking at sort of the advice we would give folks looking at how to potentially structure a serverless application, the actual physical structure of how it's laid out and what it's made up of. And I wanted to get started by taking a look at one of the first aspects that often comes up with folks is looking at the service size and how big should services be, how many should we have, and so on. And generally, we can break this up into sort of two sections when you're starting out building a serverless application. And even if you've been building serverless applications for a long time, you might be starting a new application, just beginning on it. Often the advice that we give is to maintain simplicity as long as possible. And that's to start with a single serverless service, single monolithic stack that you are building your entire application under. And this becomes useful for a number of reasons, because breaking apart a application right in the beginning when you're just getting going is kind of hard to do because you don't always know what your service boundaries might look like. So the idea here is maintaining under a single stack doesn't force you to make decisions that you might regret later. And it also allows you to keep everything more self-contained and easily discoverable. All your code and configuration is together in one place. And this becomes useful when you're growing your team that you need for building your application. As new people join the team, everything is together in a single location. It makes it a lot easier for folks to continue to build and progress from that point on. Ultimately, as well, simplicity is key. And if your application never needs to be broken up into multiple services, that's fantastic. A single service may be all you ever need. But of course, as time goes on and you start adding more features, you start solving more problems that your customers have, your application will grow. And eventually you'll reach a stage where looking at breaking up the single large stack becomes a simpler process to manage multiple smaller services than a single large one. And this is when you should start looking at potentially breaking up your single stack into multiple ones. In that case, splitting then becomes the best choice to maintain the simplicity that we want to keep as we go. Now, deciding on what size and how big these services should be is a tricky one. This is a pretty big discussion to have. Generally, the guidance that we tend to offer is, as long as the domain is relatively cohesive and sort of sensibly bound, I know that's kind of ambiguous as well. It's a very difficult one to pin down. But as long as it's cohesive and sensibly bound, it tends to be the best way to size them. And the size of services will differ, depending on the organization that you're working in, your team structure, even the application itself. And an example of this that I often use to sort of demonstrate what I mean by cohesive and sensibly bound is something like, if you think about in a microservices environment, I might have a user management service and I might have an authentication service. They might be separate services, but if you stuck them together, that is still sort of cohesive and sensibly bound. So why not just do that? Make your life a little bit simpler, yet you are still splitting out into multiple services. And why should you split? What is the impetus to make you want to split? Well, first of all, there can just be some AWS service limits that get in the way. In the past, this used to be the CloudFormation stack size. That's recently been increased by AWS, so thank goodness for that. But you can still hit across this limitation. And there are other service limitations as well. Cloud IAM, for example, has some limitations on the document sizes for permissions. When a single service starts growing this document size, you can start hitting up against those limitations, and a number of others. But the advantage that you also get from splitting up a service is that now you can make the most out of capacity for different cloud services. So API Gateway, for example, has limits on a single API Gateway endpoint or resource as to how much traffic it can actually handle per second or per minute. And you have the opportunity with multiple services to use multiple API Gateway resources to help increase the amount of capacity available to you for your entire application. Region limits is a similar situation. If you have multiple services and you start hitting up against regional limits for specific services, like AWS Lambda, for example, in a lot of regions, Lambda can only handle 1,000 concurrent Lambda functions concurrently. So by having multiple services, you can optionally split these services out into multiple regions and make use of a lot of capacity available to you in that way. Ultimately, as well, this can also just be a logistical thing. As the number of developers in the team grows, you might decide that splitting up your single team into multiple smaller teams is the best way to go. And having multiple services in this way helps, because now you can aggregate collections of services together with the teams that should be responsible for maintaining them over time. So it could also just be a logistical decision in that case. And now you've grown and you've gotten to the point where you have multiple services. Now your services need to communicate between each other. And ultimately, you end up having the choice between two different types of communication. You can have asynchronous communication between your services, or synchronous communication, obviously, is the alternative. Asynchronous communication is a method based on using an intermediate messaging service like an event bridge, SNS, SQS, and many others out there to help you propagate a message from one service to another. So instead of directly sending messages. This is also generally the preferred method recommended because there are a lot of benefits to using asynchronous communication methods. One of the large ones is that this can reduce perceived latency. And if you have a client, for example, making a request to an API gateway endpoint, if you're accessing downstream services using asynchronous communication methods where you drop a message and respond, your returns to the client request end up being really quick. So that perceived latency that a lot of clients receive is diminished. It also means that you can reduce the load on downstream systems, because a lot of these messaging services from AWS allow you to control how messages spin up additional Lambda functions to execute. Kinesis and SQS, for example, can be handled through polling and batches of messages. So this allows you to manage the load on those downstream systems. It also helps you reduce cost over time, especially on AWS Lambda, because instead of having a compute module like Lambda sitting, costing you per millisecond while you're waiting for responses from downstream systems, asynchronous communication methods let you drop a message and return and end execution of Lambda. So you're no longer incurring an extra bill. And because of the way that Amazon has built these services, you get the increased durability due to the automated retry mechanisms available in these systems. Kinesis, for example, can hold messages up to 24 hours, and you can increase that to 7 days. So if a message doesn't get through to the recipient on the other end, Kinesis can keep those messages until you can fix the problem, and then you can continue sending them. These kinds of retry mechanisms exist across all of these message services to some degree. They vary. Now, the alternative to asynchronous is obviously synchronous, and this is usually accomplished through making HTTP requests or even direct Lambda invocations using the AWS SDK, and it's often used as a last resort when this is the only potential way to send a message to a downstream service or system that you need to communicate to. The reason why this is usually not a recommended communication method is the durability issues that you have. Without the automated retry mechanisms that you get from asynchronous communications services, this means that if you're making an HTTP request, you're the one who's responsible in your code to manage retries and so on. Not to mention, as I said before, with asynchronous, using synchronous communication methods, you could have a chain of synchronous communication methods, all adding latency to your application. And then you have to wait for responses to come all the way back up that chain. And that just makes your application feel slow and sluggish. The biggest one, though, is your downstream services can ultimately get overwhelmed with requests. So if you are seeing downstream systems getting affected by inundated with requests, you may need to look at dropping in an asynchronous messaging system just to help manage that load more cleanly for you. I'm going to pause here, and I just see Bob Pease has got a question, so I'm just going to answer that quickly. He says, when building asynchronous systems, how difficult is it to change the tech stack? For example, starting with SQS and later on changing to Kinesis. So thankfully, the changes are far more complicated switching from something like API Gateway to one of the other services, because the entire event object that the Lambda function receives is completely different. Whereas with switching from something like SQS, SNS, Kinesis, and so on, the general structure of those event objects remain the same. It's just the small nuances of the object structures you might need to tweak. So ultimately, how you deal with the data you receive will not change necessarily with these asynchronous systems, as long as you're moving from one polling mechanism to another. So if you're using SQS, which you need to poll, to Kinesis, which you need to poll, you're generally going to be okay. They'll batch. If you're moving from others like EventBridge to SNS, they work because they're not polling. They will actually trigger execution as messages get sent. So if you stick to the same type of technology, generally kind of simple. The things you'll have to change is how you read the messages out of the event object. That's what will change. So there will be changes, but they're not terribly complicated. However, if you are using SQS and you're looking at switching to another technology, I'd suggest sticking with the technology you're using unless you have very compelling reasons not to. Making changes like that can be potentially dangerous and just cause bugs and so on. So what's the best practice for sharing code between Lambda functions? Chris Moy asked, and we will get to that. Thanks, Chris. So just hang on, we're getting right there. All right. So one aspect that often comes up when folks are looking at how to structure a serverless application is looking at shared infrastructure. And this comes up because often you have infrastructure like DynamoDB tables, relational databases, Redshift, Elasticsearch, Elasticache, any of these systems that you can have multiple services communicating to. How do you deal with that? Because the model with Serverless Framework is that you can define these in your resources section in your serverless.yaml file with CloudFormation, and that's a great feature to have. However, these shared resources don't have a home service. So how do you know where to store these, where to configure these? You can't configure them across every service because then you end up with conflicts because they already exist from a previously deployed service. So how to manage that cleanly? A lot of organizations use alternative infrastructure as code tools, which is a tactic that is plausible. However, you can use the serverless framework for this by just using a specific service just set aside for these types of shared infrastructure elements. So if you need to spin up a relational database or a Redshift cluster and so on, you can use the CloudFormation in a specific resources service that you set aside for this purpose. And there's many advantages to doing this. One of them being that, bear in mind that most of these services only ever get deployed once, and they rarely ever get redeployed again. Only in extreme circumstances will you then go and deploy over an existing relational database to tweak it or change it, for example. That doesn't happen very often. And this is important to bear in mind when most services, you'll be making a lot of code changes potentially and redeploying multiple times. And by having a separate service, this means that these multiple redeploys of code-heavy services won't accidentally update these the shared infrastructure that should rarely change, and avoid any accidental updates that you might make. The biggest advantage to me, though, of this is that this ends up giving you greater control. These types of shared infrastructure tend not to be cattle but cows, and you need to look after them very carefully. They're usually data services as well, so you want to have that great control, especially in production, just to manage that. And then ultimately, we also get questions around Git repository structure and how best to lay out the services within a Git repo to manage them more effectively. And again, starting out, the general recommendation we'll make is to use a single monorepo for all your services. Keep everything all together, because at this point, a multi-repo environment doesn't really add much benefit and can add potentially a lot of complexity for no real benefit. It also makes it a lot easier to keep track of existing services, especially as you're onboarding new members to your team. You're going to see they can pull a single repo down, see all the services that you have available, and immediately know where to go to start working on things. There's also, with the recent release now of Serverless Compose as a feature of the Serverless Framework, deployment orchestration in a monorepo is really possible. And having the monorepo means that you can better manage the dependencies between your various services, which is pretty cool. Now, sharing code was the question that Chris Moyer asked about. And again, a monorepo makes this a relatively simple task where you can have a single folder that you can store shared code, and all your services can just include whatever code they need to from a shared folder, for example, or whatever else, however you decide to structure this within your monorepo. So that's pretty useful. However, as you grow over time, again, especially as you start going into a multi-team environment, having this single repository might start getting a little difficult to maintain over time. So this is where we would recommend that you break up your single repository into multiple repositories for each team. But ultimately, each team is going to have their own monorepo of multiple services. Now, this sort of breaks the sharing code idea. So that makes things a little bit more trickier when it comes to sharing code. But when you do start reaching the multi-team scale, now it becomes really beneficial to take a look at the package managers for the runtimes you use in your serverless framework services, like NPM, for example, with Node, pip for Python, and so on. And most of these package managers have ways for you to have your own private repositories as well. So it becomes a lot cleaner to manage your shared code through these kind of package management systems on a multi-team and that large-scale environment. So I hope that helps answer things for you, Chris. And now, one of the other aspects of building a serverless application, and Stephen has mentioned this in the beginning, is the Serverless Inc. has been building tools to try to help developers keep better monitoring and observability on their serverless applications. And Serverless Console is our product that helps do that. It gives you immediate access to metrics of the application you're busy building and once in production with no additional configuration. There's essentially 2 lines that you add into your serverless.yaml file to add it to the console to allow you to get this data available to you. And it also gives you very quick and easy access to logs and performance data to relate it to specific Lambda functions. So let's take a look at console so you can see what I'm talking about. And I'm just going to share a screen here. And it should be that one. There we are. There we go. So what you can see I've got going here, this is the Serverless Console, and this is the product that we've been building along with some customers as well. So this is available for anybody right now to use and test and give us feedback on. But the whole idea of Console is to give you immediate views on information that's important to you. And I can switch from a function view here to a API view so that I can go ahead and view my API endpoints instead of my functions, if that's what I wish to do, with a lot more of these metric views as well that are going to be developed over time. This is over the last 24 hours. And as I said, the whole idea here is to give me instant information about what's important. And immediately errors pops out here as a very important thing I might want to look at. So I'm just going to click on that. And immediately it's going to filter out everything else but the errors so I can take a look at that. And in this view, I can see create comment is the function causing all my errors. Let's click through to one of these bars to filter through to the actual invocations causing my errors. And here I've got a list of 3 of them. So let's just take a look at one, look at that in a bit more detail. And now I'm starting to get into some really useful information to help me solve potential issues with this Lambda function. I have my response that I've sent back to API Gateway, as well as the full event object that's been passed to the Lambda function for me to potentially debug with and replay my functions. But what's useful for debugging an error is taking a look at my logs. And immediately you can see I've got a message here saying the user has non-admin and needs admin, and a full stack trace here as well, so that I can debug this further down the chain. But what this means is that what I could do with this information is user has non-admin. Let's go back to my timeline, because my event object here is going to show me I have a authorizer. This is data that I've passed. I've set a role in my authorizer as non-admin. There's my error. So now I know exactly where to go ahead and fix this issue. Of course, looking at logs, often the issues aren't quite as easy to solve as that, and you may need to get additional members of your team on board. So what we've done as well with Console is allow you to click a specific log line, copy the URL from that, and send that to anybody else in your team, and they will get directed straight to the exact log line that you've selected as well, so that everybody's on the same page and can start debugging far more complex issues to try and correct and get your Lambda functions running like they need to. Now, just going back to this timeline feature, I'm sure you've seen here, we have the timeline for an AWS Lambda function here. There isn't a lot of detail here, but let's take a look at something that does have a bit more. And the whole idea of the timeline feature is to give me performance information about my Lambda functions that have been executing. And if, for example, I decided that this specific invocation was problematic and was taking too long to run, I can take a look at my timeline and immediately see what might be causing my issues. And here immediately, this HTTPS post and the URL that's affected it might be what I need to go look at to go and debug this and reduce the execution time. This immediately makes it obvious. My code sitting here is not causing any problem. And you might be wondering how we're getting this middleware data. Fortunately, the console uses the OpenTelemetry protocol and libraries. So any framework that you might use that supports it as well, like Express, will automatically be instrumented for you with no additional configuration or libraries or anything else that you need to manage. So this middleware data here that I'm seeing from my Express application is instantly given to me. And I can see those are not my problem. Those are executing pretty quickly. But you might be wondering, how do I get to a specific invocation? Well, using the Explorer view, I can now filter my data in many ways. I am able to track down in all sorts of different metrics what I might be looking for. But let's say I want to look for something with a function duration that is longer than 2 seconds. Let's just filter by that. Let's say I do that over the last 7 days, because apparently 24 hours, nothing was running terribly long. Here we go. I've got 2 of them. Let's go and look in more detail. I can go through to this one. Why was this 2 seconds long? Immediately I can see my Lambda execution time was actually only 114 milliseconds, but the full duration was 2 seconds. Let's open up some more information. This was a cold start. So if I don't have anything performing badly, but my cold start seemed to be, now I know that that might be something I'm going to go focus on. Perhaps I should go look at cold start mitigation strategies if this is affecting me negatively. This is the kind of information we can get through Console, immediate information to help me potentially solve problems. And like I said, it's available to everybody to use right now. I believe the link was posted by Richard, so we can go through to the Getting Started documentation. And yeah, feel free to try it out and give us some feedback so we can build the product that will help everybody who needs it. And I'm going to now take some questions. I see we have one more question from Ryan Token. Is the GitHub repo the best place to leave feedback on Console? What I would recommend is we have a serverless community Slack, and that's a great place to get in touch with myself if you need to. You can find me on there, or others on the team. Maybe we can share that information as well at some point, Stephen, who folks can get in contact with that have been trying Console if they want to give feedback. But at this point, feel free to send me a message in the community Slack if you have some feedback on Console. I'll make sure to share that with the product team on Console.
Yep. We do have a dedicated Console channel within that Slack workspace as well. So, that's definitely an option. But I think the serverless channel, the serverless community Slack is a great place to start. All right. So thank you, Gareth. Before we move on and to Purple Technologies, Serverless Journey, are there any other final questions for Gareth? If you do, go ahead and type them in the questions tab. We'll give folks maybe a couple of seconds, and then if we don't see any any questions there, we'll move on.
If anybody does have questions later, or you suddenly come up on things, feel free to message me again in the community Slack. I'm more than happy to chat to folks if you've got questions about Serverless Framework. Don't be shy.
Great. All right, thanks, Gareth. So why don't we transition and tee up Filip and Jan for sharing their serverless journey at Purple Technology.
Thank you, Stephen, and hello, everybody. It's great to have the chance to talk about our journey with serverless, which we are quite enjoying. I will start with the brief introduction of what we actually do, who we are, and then transition to Filip, who's our serverless architect, and he will talk in more details about how exactly we use serverless and what are the benefits for us. So we are a technology company, and we work with fintechs, mostly brokerages. We have long-term partners that we cooperate with, and we make sure they can focus on business. So things like sales, regulation, all those things, which is like very, very tricky in this environment. And they don't have to build their own in-house technical teams. And we also provide other services like some legal counsel and other things. But here we focus on tech, so let's stick with that. And we make sure they can be quite lean, quite focused on their business advantages, and we can provide the technology and experience in building complex systems. So basically, what we build are apps, web apps, and moving into mobile as well, that allow the clients of those brokerages to manage their investments and their accounts. So to open an account with any like financial firm, if you have ever done that, you have to go through complex onboarding system first. You have to provide a lot of information about yourself, so the brokerage can be sure that they know who you are and that you are not a terrorist or something like that. So they're safe to handle your money. And we provide tools and interfaces for the brokerage to do that quite easily, quite efficiently, without too many people on staff doing everything manually. So we try to automate as much as possible to make it easy for the admins to approve or deny requests for accounts, and then for like things like deposits, withdrawals, and account openings, everything in that area. And we focus on making it easy and efficient, both for the brokerage and for the client as well. We do have some short videos to go through to demo our products. So let's take a look at that. This is a dashboard of one of the brokerages, where you can see actions that the client did inside his account. He can filter for example, transfers in between accounts, see the history, and he can make a deposit to one of his accounts, pick a different payment method, and see instructions for that. So yeah, and or a card deposit, again, it's a payment gateway, so he just inputs his detail and it's automatically processed. Or he can transfer in between two accounts, again, inputs an amount and just makes a transfer. And again, the goal here is to make it as easy as possible for the client to manage the account. Yeah, there is also a section about managing personal details. Again, if you want to change anything, it has to go to approval for the team that's making sure that, for example, you are uploading a new ID document, so they have to check that everything's all right and approve it. So the interface is quite straightforward, but then the actual processes behind those are always quite complex, because there are always exceptions for different countries, different jurisdictions, what you can approve or cannot, what can be automatic, what needs to be verified manually, and all those things. And I was talking about the onboarding process, so let's demo that as well. So here is like an onboarding form where you input your personal details. For the first step, it's quite simple: name, email, stuff like that. But then you move to more complex part, where you have to pick the type of account you want. You decide you want a live account. You pick some of the parameters of that account. Then again, a bit more complex information about yourself. Just move it forward. And for example, here there are checks that if the residence and the place of birth is different from the ID you upload, again, we have to verify it a different way. So many things like that. Then the documents you have to actually verify are here. So again, you have to choose the country you are your document has been issued from. Pick the type of the document you want to use. And take a photo of the document. Well, I'm not sharing the document here, so don't worry. So this is the end of the video. I think we can close it now and get back. Oh, and we've lost the presentation, it seems. So guys, if you can share that again, please. Perfect, we're back. So that's a brief intro into what we actually do. Let me pause here if you have any questions, but I guess we'll now move to the more interesting stuff of how exactly serverless plays a role here and why.
All right.
I guess there are no questions for now. So yeah, Filip, it's your turn now.
All right. Hi, guys. So let's take a look at our serverless journey at Purple Technology. Basically, in 2017, it was our first contact with serverless. We were trying to search for some service which could solve some use case for us, and we found it. It is called AWS Functions, which we'll talk about later. And that was the reason, basically, why we started researching serverless and eventually took the risk of this early technology and adopted it. And in 2019, we started playing around. We started building simple apps. We started developing the APIs for our applications, and we liked it, and it was growing over time. And the most important part, we were learning the serverless philosophy. How exactly to build applications so it really takes advantage of all the serverless features. And it's not just some traditional application moved from Kubernetes just to a Lambda. And in 2019, we decided to do a level up. We gathered all our know-how and skills, and we put together something we call Purple Stack, which I will show you in a minute, where all our experience is stored, and we are using it for all of our big applications, basically. And we started rewriting back then our biggest application to serverless. In 2020, we did a partial release of that application, and we were waiting for things to go wrong, basically, where serverless might not be sufficient. But in 2021, we released the whole application, and we still didn't see any issues with serverless. So that was the year where we could say, like, okay, it's confirmed. Serverless is really working for us, and it will work in the future. So a bit more about the philosophy. Back then, when we were planning how to build a purple stack, basically it was our station from which we will build all our new applications going forward. We built it on 3 main pillars. One was serverless, then was infrastructure as code, and then CI/CD. Basically, serverless, nowadays we can say, of course, serverless, but back then it was not taken for granted. So it was an important part. Infrastructure as code, well, we didn't know infrastructure as code before because we were mostly developers or only developers. And we were trying to figure out like how to run the applications without having any operations guys. And we found infrastructure as code and we started to like it a lot because it brings transparency and better maintainability to the applications. And the next thing was that as the team grew, we were not able anymore to deploy the apps from local. And we needed proper CI/CD deterministic environment from which we can deploy all the applications. So we stuck with CircuitCi. Here's a brief introduction of the technologies we have in Purple Stack. It's not really like a serverless framework, like open source thing, like which you can now take and use, and it's ready for you with all the support team and community and stuff. It's more about us sharing with you as a community, like what we figure out along the way, so you can take a look around and eventually take some of the parts from Purple Stack and use it in your repos. Basically, here I will show what Gareth was saying with all these monorepos, multiple services, resources, and stuff. So the services we use there, we writing the code in TypeScript. For deployments, we use Serverless Framework. Front end is powered by Next.js. We are currently packaging all the code with Webpack. Hopefully soon we will get to ESBuild. When we started, there was no other option than Lerna for having monorepo. So we might switch to Turbo Repo or something like that in near future. We have code linting, GraphQL API, REST API through AWS services like AppSync and API Gateway. Obviously, infrastructure as code, CI/CD. We have feature deployments, so all developers can deploy their features of the whole monorepo. It can take the first deploy up to 30 minutes in case of the big repos, but then we have these incremental updates, and basically the developer has his own environment where he can play around and not be afraid of breaking things. So that's very nice for supporting the innovation. And also we have like dependency patching through Renovate, infrastructure scanning, unit test, conventional commits, etc. Here's a brief architecture of our applications. Those are basically the web applications, we can say. So you need some front end, you need authentication, you need API, and some sort of a backend for these background processes Jan was talking about. So let's take a look at the individual parts of the infrastructure inside the code. So hello there, here is Purple Stack. And first thing here is API. So let's take a look how we structure our API. You can see we have some TypeScript configurations, Webpack configurations, obviously serverless YAML, and then source, schema. Yeah, quite simple, I would say. We are using some plugins, which is important to mention. Of course, serverless Webpack for supporting TypeScript, serverless plugin for AWS alerts, which we are using in combination with AWS chatbot for getting error notifications to Slack. And we are also using AppSync plugin and AppSync simulator, which we'll show in a bit, for developing GraphQL. And also we have the serverless Git branch stage plugin, which we developed ourselves, which allows us to basically create dynamically a serverless framework stage from Git branch so that developers can deploy their own branches. So here we go. Here we have the GraphQL API schema. We can separate it to multiple files to make it more observable. Then we need to start serverless offline start script, basically, and we get this URL for running the GraphIQL. And here you can see the classic, it's taken from Amplify, actually, classic GraphIQL interface, and you can run and develop your GraphQL API locally. Here we can see the folder structure of the mutations and queries. Here you can see like add to do, remove to do, being mutations, or query called to dos. And we are using this GraphQL types, which are generated by GraphQL code gen, which generates TypeScript types from a GraphQL schema. And then you can so nicely use it in the code and have everything being type checked, which is very important part of our applications for them to be sure that nothing gets broken. So the static type analysis is very useful for us. And basically this part highlighted, you can see on the schema, this was the API, basically the app sync together with Lambda resolvers. Next thing is a huge shout out to AWS Functions. As I mentioned, it's one of the reasons why we adopted serverless in the first place, because we need to have insights into the individual business processes which are happening inside the system. And for example, when the client is registering, it's a very huge diagram of different procedures and stuff. And on the right side of the presentation, you can see example of one of our state machines. There are many different steps, some of them running in parallel. And we can take a look at every single process, what is going on. And eventually, if there is some issue, we can respond much quickly because we know in what status is the system, and we can see it very clearly in the console. So as Gareth mentioned, we have this resources folder in our monorepo where we are storing basically all the persistent resources like DynamoDB tables, S3 buckets, and stuff like that. And very important part of that is actually, Very important part of that is actually exporting these values as CloudFormation exports so that they can be imported in other serverless services. So, and that way you can link the stacks between each other and have unidirectional dependencies. Excuse me. And basically, this is this part. You can see in the diagram, the resources like DynamoDB eventually can be also RDS, SNS SQS, or Cognito, which are all the parts which are being reused by all the other parts of the applications. And next thing is a service itself. For example, in this case, we have a service called add to do, which contains a state machine, which basically does, which adds the to-do to the table. And here you can see the example of importing the value from resources. Here we are importing the to-do table ARN and using it inside the permission statement so that the Lambda function has access actually to the table and can put the item there. And down here we can see, here's a question. Lambda resolvers exclusively with AppSync, WTL. Yeah, basically we are using only Lambda resolvers with AppSync, if I answer the question about the API. And we are not using the direct service integration in AppSync, so that because it gets quite complex, because developers are used to writing TypeScript code, and if you start adding more complexity like okay, you cannot find this feature inside the source code itself. You find it in the infrastructure definition. It started to be a bit messy, so we stick around with keeping it only in Lambda resolvers. I hope I answered the question. Next, getting back to the state machine. Here we have a function add, which simply contains a source code for adding item to DynamoDB table. And let me move the slide. And here we have the state machine, very simple state machine with one step where we just reference the add function, and basically that's it. And again, because we need to start the state machine inside API, which is another serverless service, we need to output it so that the API can then import it and reference it, and we keep the references across the whole monorepo stack in the deployment. And basically, this was this part, which we call essentially backend of our applications. Next thing is frontend. As I mentioned, on frontend, we are using Next.js, and we are using static exports. So on some projects, we are already experimenting with some server-side rendering, or at least some better routing with dynamic routes. And here we are using also some plugins, namely Serverless Finch, which is quite good for uploading the static files to the S3 bucket, actually. Yeah, and here we can see the configuration. So we are uploading the files there, and then it's being accessed through sorry, through CloudFront. Any questions to that? Don't see any. All right, so let's move on. Why serverless? What are the technical benefits of using serverless? Well, we don't have any unexpected fatal errors. Like we still have some Kubernetes legacy infrastructure, and what happens there that we are getting some reports like, well, suddenly this container is down, and we don't know why. So we will just restart it, and we don't have to worry about anything like that with serverless, because the cloud provider takes care about that. We have no downtime. We didn't notice any downtime basically, because still the cloud provider makes sure there is no downtime. And there's no need for 24/7 operations team monitoring, because up until now we wanted to have it because of the reason I mentioned, like suddenly the container goes down and somebody needs to restart it or something like that. And we have this story where we were asked by our colleague, like, let's have a talk about some like fuck up nights meetup, where like what fuck ups you guys have with serverless. And we're like, well, it sounds really awkward, but we can't really think of any. Like all the errors and mistakes are related to the application itself and not to the serverless infrastructure, actually. How does it help your team with velocity and flexibility, you might ask? Well, developers can only focus on business logic. That's one of the important parts for us about serverless, because developers are a very precious resource nowadays, and that's what your business needs. You want to invest money only into things which are bringing in the biggest added value to your business. And new developers can start quickly by focusing on isolated parts, because when you have some monolithic legacy application running in your Kubernetes, there is a lot of mess around, like having some API framework for handling API routes, etc., with all these different middlewares and stuff. And there can be some hidden magic inside, and the time developer must spend when like researching can be sometimes very long. And with serverless, you can just tell him, okay, here we just add this route and link it to your Lambda function, and that's it. And you can start developing now. And one interesting part for us is also that non-developers can actually perform actions in AWS Console. Like, for example, in DynamoDB, we have some configuration of our application there, and the business people can come in and basically just change the configuration there, and they don't need to contact developers, which is also very time-saving. And also, we have more time for developing new features than maintaining existing infrastructure. That's very helpful. So what are the business benefits? Some of them I already mentioned. So we have less code, which means we have less liability and also less maintenance work. So we can focus on building new features rather than maintaining the existing infrastructure. Our processes are transparent and self-documenting. That's related to step functions, where the definition of the state machine is basically documentation of the software itself. And the business people can see of what steps the software is composed. And that's very helpful. And the biggest added value is the team efficiency, as I mentioned. Like a server-based legacy app could take in our, based on our data, could take like 1 week to develop a new feature, because there was a lot of mess, and it was really not transparent, a lot of code there. But with serverless app, there is only the business logic and nothing else, and it was much faster. So we can talk about like comparing 1 week versus 1 day. It can get this much different. And since we have still some Kubernetes clusters for the legacy applications, we can measure that approximately we are saving more than 10 times on the cost compared serverless versus Kubernetes, because our business is based on certain traffic coming from certain time zones. And also there is no traffic during weekends. So in this case, serverless really shines, and we only pay for the traffic which we use. And the managed services are lowering the development cost. So you don't need to develop your API gateway or manage it. You don't need to develop your AppSync, API, S3 buckets. Everything is provided by the cloud provider. It has been a very long time ago when we were considering any alternatives. So here I mentioned some. It can be Kubernetes, AWS Beanstalk, Heroku, but really for us, we see no reason why switching to these. And I guess we can answer some questions. I can see here a question from Alexander. In terms of CI/CD, are you deploying all the services every time change is detected? Do you use any mechanism to only deploy the changed services? Very good question, Alexander. Yes, it became a problem because we started having deploy times like 30 minutes, which was really bad. And that's why we developed actually, we call it Learn a Smart Run. You can find it on our blog, on our website, and on our GitHub. And basically that's a feature which tags your repo and then detects the changes based on the tags. And basically that's how we deploy only things that changed. So that's a very good point, and it's quite important for managing big monorepos. Next is from Gareth. What do you estimate you save in costs by not needing so many DevOps engineers on the team managing on infrastructure? Well, not sure about that. I guess Honza can have some.
I can answer that. Like, for example, what we deal with is the 24/7 support. So with the Kubernetes systems, we really need to have ongoing monitoring. So we are outsourcing that currently to an external company, because we don't want to build a team that can really, like, you have to have at least 3-4 people on call, basically monitoring it all the time if you want to make sure that every minute is covered, and the people can sometimes take vacations and stuff. So so that becomes quite costly. And also for the DevOps, again, like with the Kubernetes, it became quite complex to solve any issues, to understand like how things are structured, and if anything's not working, we had to have dedicated DevOps people taking care of that. We never had internal DevOps teams because we always outsourced that. We always wanted to stay focused on the business logic and the development itself, and not managing servers. So we've always been looking for shortcuts that led us to serverless in the end. But it's very hard to say like exact cost, because it's of course different for every company. But you like can compare a team of 5 people to like 1 or 2 that are managing the infrastructure on serverless and doing many other things as well. So it's like 5 times difference, something like that.
And also there was a question from Steven. Did you have similar experience that Gareth described earlier as your app crew, splitting services and repos? Yes, basically, I think that was quite accurate. We were used to having everything in single serverless service, and then as we found out that if you want to grow and scale, we need to split it. And also there were many other reasons for having the monorepo, as Gareth mentioned. So yeah, that was actually quite a good point. Yeah, we are the same way. And last thing to mention, we are hiring serverless engineers. So if you really want to work with serverless and push it forward, we are the company to go. If you live in Central Europe, for example, Slovakia, Czech Republic, we have office in the Czech Republic and headquarters, but we are also open to any remote cooperations. We are looking for serverless engineers, full stack TypeScript developers, and also, as Hunter mentioned, we are starting our iOS, Android, and React Native teams. And I guess that's it for me. Thank you, guys.
Thank you, guys. A couple slides here. These are the resources from today's call. I also threw that over in the chat. First and foremost, I want to thank everybody for joining today's community call, and I hope you learned as much as I did from our guests today. And of course, I hope you all enjoyed yourselves and were able to get your questions answered. If you have any outstanding questions, please throw them over in the questions tab right now, and we can still try to answer them as we are coming to the end of today's call. I'm going to post... Yeah,
let me just jump in. Have we shared the GitHub repo with the purple stack? I think that might be helpful for people. I'm not seeing it in the links, so maybe we can quickly... Filip, maybe if you can just post it there, I think you'll have the link handy.
Yeah, if you have it and want to toss it in the chat window, that'd be great. And then everyone would have access to it. And then if you can send it to me after, I'll include it in all the links for that. Oh, there we go.
Awesome. Yeah, thank you. Yeah, Filip mentioned it multiple times, so I think it will be quite handy for everyone watching.
Thank you for doing that. Yeah, and all of these links will also be available after today's call in an email that will go out, and it'll also be in the description of the video itself. One last thing that I will mention is we are actively looking for serverless users to share their serverless story with us. So please use that link that you see there in the chat, submit your serverless story. And we are interested in like blog collaboration, joining us for a community call like this one, or just a full case study. We're also giving out some top-notch serverless t-shirts to those of you who reach out and help us put this content together. We want to make sure these shirts were pretty much your favorite shirt, so we did not hold back on the quality, and they're definitely worth getting your hands on one. And then finally, be on the lookout for our next community call, which is tentatively set for June 1st. There's not an event page yet, but we'll get that up pretty shortly here. And feel free to reach out to myself or any of my team members and let us know what you would like to hear content-wise in some of our upcoming calls, because we're definitely looking for the feedback from you guys as to what you guys want to hear in these calls and what you want to learn from. And unless there's any final questions, I'll put a wrap on this. And again, thanks to Filip, thanks to Jan, everyone from Purple Technology, and thank you, Gareth, and thank you, Stephen. And I hope you all have a great rest of your day.
Great. Thanks, Richard.
Thank you, everyone.
Thanks
Thanks,
again,
Richard.
everyone. And thanks for joining.